other things. This is chapter 19. So, resistance capacitance circuits. All right, so that's
what was that meter at the top talking about, an ohm or what?
let me see. This thing, a digital multimeter. Looks like it's measuring amps from the, looking at the bottom.
Yeah, I carry one of those. Those aren't cheap. That's one.
Oh, they measure voltage, current, and resistance all over a wide range.
Pretty much anything else.
Okay, so the one we did last time is the one on the next page. So the resistance capacitance circuit where you don't have a battery, but this capacitor starts at charge. That's the one we just did. This one is kind of the other extreme case where you start out, you do have a battery, but you don't have any charge initially on the capacitor. So you've got I is still the same formula as before, but Q, well, there's no initial Q, right? Because we're charging the capacitor, so it should start at 0. So the only difference is instead of Q having E to the minus T over RC, you have 1 minus. That way it starts at 0 and gets bigger. Right.
It's not negative RC. What's in front of the R?
Yeah. Wow, this is working poorly. You wouldn't think scrolling the screen would be that hard.
We understood the maths.
Okay, forget that. Let's make it regular size again. Let's get rid of that. Wait, what? Oh, no, get rid of that. All right. Now, for some reason, I can't get the thing to scroll down at all. Why is it doing that? Oh. Yeah, you did. Okay, I'm going to try just closing it and opening it again. Anyway, it's the same formula, but instead of E to the minus T over RC, it's 1 minus that.
So it's still T over RC?
Yes, it's still E to the minus T over RC. I don't know what you actually asked. But
I asked because it looked different on that. Like
okay.
We had it multiplied by RC.
Okay, gotcha. So just as the circuit's completed, what's the voltage drop across the capacitor? Well, again, the voltage drop across the capacitor is Q over C. But when we're just first connecting this thing, there is no Q on the capacitor. So initially it's 0. Which means what's the voltage drop across the resistor? Well, it has to be whatever the voltage you pick up at the battery is. So that's 501. Oh, I guess I should hit submit on both these. Just after the circuit's complete, what's the charge on the capacitor? Well, that's 0 because that's the reason we said the voltage drop is 0. Okay, here's something that's not 0. So just as the circuit's completed, what's the current through the resistor? Well, initially it's like the capacitor is not there at all. So it's just going to be current times resistance is voltage, right? Well, let me pull that back up so you can see it's just this V equals IR is the only thing that's going to be happening. So just voltage divided by resistance. Which 501, yeah. I mean, voltage is current times resistance. Right. And we're looking for the current. So we're going to go voltage divided by resistance to get current. All right, so 501 divided by 4300 is 0.117. And then a long time after the circuit's completed, so apparently this one we didn't really need to know the formulas because they're only asking us about the initial and the long-term effect. Long-term effect, the current quits going, and all of a sudden you've built up all this charge on it. So basically in the long term, it's like the resistor is not there, you just have the capacitor. So the voltage drop across the capacitor is the entire 501. Voltage drop across the resistor is 0. The charge, well again, the C is Q over V. So to get the charge, we're just going to go the C times the V. So 501 times 6.6, and that's times 10 to the minus 6, so it would be 3.31 times 10 to the minus 3. And then the current in the long run, again, the current stops flowing in the long run, so that's 0. Okay. Cool. I say that's pretty well victory over homework 4. For half the class, anyway. I guess we're further along than I thought we were. Because
We're like way ahead.
yeah, we're way ahead, aren't we? Of course, I guess that's because I'm being silly. I mean, the reason I started doing the physics on Sunday and not on Tuesday like the rest of my classes is because I used to have a lot of people that were taking calculus and physics at the same time. Having everything due on Tuesday was not happy. So I guess we could have had stuff due on, we can have it due on Tuesday if you want. It didn't sound like anybody wanted to. All right. So we all have a couple more homeworks to work on now. Let's look on homework 4. Yeah, it's easy to get ahead in this. Again, homeworks 3 through about 6 are kind of the easiest part of the class. So it's see, I only see 1 3, no 2 3s in the whole bunch. Let's look at these 2s here at the beginning.